The next skill to be able to do is to divide fractions. And as always, we want to be picturing the size of fractions by drawing rectangles or other shapes. And let's start off with some easier ones. Something like 4/6 divided by 2. So in this case, as always, we're drawing our rectangle. We have 4/6. There we go, 4/6. So now we're saying 4/6, we want to divide that into two parts. So here's our 4/6. Divide that into 2, which is the same as half. We can see that is equal to this area here. And this is 2/6 out of our original whole rectangle. So 4/6 divided by 2 equals 2/6. So drawing pictures is always a method that we can use for solving these. They do get harder, something like 3/5 divided by 1/2. So for these, we need to actually think, what is the question asking? So we're saying, how many lots of 1/2 are in 3/5? So we'll start with our 3/5. Here's 3/5. And we're saying, how many times does 1/2 fit into that length? And we always can estimate 1/2. Here's a whole, half is here. So we're saying, how many times does this length here fit into this length here? So we can see it fits in one time because it's from here to here, but there's a little bit more, a little bit extra. So we know it's going to be a little bit more than 1. But we can't really estimate that using the picture or find it exactly. So when dividing fractions gets too hard to do a picture, there's a shortcut method that we can use. And it's something that we should always remember. It's called keep, switch, flip. Keep, switch, flip. And that means you keep the first fraction as it was. So we'll practice with our example from before. 3/5 divided by 1/2. Keep the first fraction as it was, 3/5. Switch means switch the sign from a divide to a multiply. So keep the first fraction. Switch the divide to a multiply, and flip the second fraction. And flip means we're writing the inverse fraction, or flipping it upside down. So the denominator was 2, that becomes the numerator, and the numerator was 1, that becomes the denominator. So we've flipped it upside down. And now we have a multiplication. And remembering our multiplication rules, 3/5 times 2, we multiply the top and multiply the bottom. That gives us 6/5. And as always, we look to simplify, and we don't have a common factor between 6 and 5, so that is our final answer. let's actually think what that means. So we found that we were asking, how many times does 1/2 fit inside 3/5? And we found the answer was 6/5. And that's an improper fraction. So we can convert that to a mixed number. 5/5 is 1, and we have 1 extra fifth. 1 and 1/5. So just like we estimated, we can fit 1/2 in 1 whole time plus a little bit extra. And it ended up being 1/5 extra. So we always want to double check our answer to check that it's reasonable or about right. And ours was exactly what we estimated. Let's practice one more division of fractions. We'll have 1/3 divided by 2/5. So we're saying how many times does 2/5 fit inside 1/3? And we'll use our keep, switch, flip. Keep the first fraction, switch the sign, and flip the second fraction. And now we're multiplying, so we have 1 times 5 is 5, 3 times 2 is 6. So 5/6 is the answer to 1/3 divided by 2/5. Which means we can't fit 2/5 inside a third. We have a little bit less. And we can compare that with a fraction wall to double check. We'll have thirds and then fifths. Here's 1/3 and here's 2/5. So how many lots of 2/5 fits inside 1/3? It's a little bit smaller. We can't fit 2/5 inside. And our answer was less than 1. So that's pretty reasonable.